Hi students, I am Ashwin sir and I am here to teach you the concept current electricity. We will discuss few things in current electricity in this class. So let's start with our class current electricity. So I am sharing the screen with you people. So today class we are going to discuss about series and parallel connection, series and parallel connection. So let's talk about in this class we are going to discuss about series and parallel connection. For example, if I am taking a circuit, first of all I am going to talk about series connection, then I am going to talk about parallel connection. So series connection. So let's start with our class. So if I am taking this one as the circuit, then what happened in this circuit? I'm taking battery, I'm taking two three resistors in the circuit, and these three resistors are in the series connection. So how you can say this one is in series connection? So if in the circuit, if same amount of current, let's call this one as battery of voltage V, let's call this one as resistance 1, let's call this one as resistance 2, let's call this one as resistance 3. So if three resistors are connected in series, then the current passing through each and every resistor is going to be common. That means if I amount of current is passing from the battery, from the circuit, then I amount of current will pass from the resistance 1, I amount of current will pass from the resistance 2, I amount of current passes from the resistor 3. That means these three resistors are in series connection. Let's call the potential drop across resistor 1 as V1. Let's call the potential drop across resistor 2 is V2. And let's call the potential drop across resistor 3 is V3. So we know if I want to write the potential drop across the ends of the wire, if I call this one as V, this one as 0. So for the connecting wire, the same potential drop will be there. So V and 0. So if I want to write V net, so V net is equal to V into V1 plus V2 plus V3. And according to Ohm's law, we know that V is equal to IR. So V net is going to be I into R net is equal to I into R1, because V1 is nothing but I into R1. And what is V2? V2 is nothing but I into R2 plus V3 is nothing but I into R3. So from this, what I can do is I can cancel out this resist I. So from this, what I will get is R net is equal to R1 plus R2 plus R3. If three resistors are connected in series, but suppose if n resistors are taken into consideration, then what is R net? Then R net is going to be R1 plus R2 and so on up to Rn. This was the things which happens in series connection. And if I want to talk about current, so what is current flowing in the circuit? Current flowing in the circuit is nothing but I is equal to V by R net. Some people will call it as R equivalent. V by or equivalent. This R net is called as R equivalent, some people call it. So this is all about in series connection. So if I am talking about parallel connection, let's go on talking about parallel connection. So what happens in parallel connection is parallel connection. So what happens in parallel connection is, for example, if I'm taking a circuit, let's call this one as the circuit. So let's take a battery here. Let's take the resistance 1 here. Let's talk about resistance 2 here. Let's take resistance 3 here. Now what happens in this one is, let's call this is voltage. Let's call this one as battery of V voltage. Let's call this one as resistance 1. Let's call this one as resistance 2. Let's call this one as resistance 3. So what happened in the circuit is, if I call this potential end as V, then this potential end is 0. Then connecting wire, due to connecting wire, this is V, this is 0, this is V, this is 0, and this is V, and this is 0. So what is common across each and every resistor? V is common. But if I amount of current have been generated in the circuit, this I amount of current have been divided into three parts. One part is I1, one part is I2, one part is I3. So I net is equal to the total current, which is nothing but I1 plus I2 plus I3. But according to Ohm's law, we know V is equal to IR. From this, what I can do is I is equal to V by R. So I net will become V net by R net is equal to, V is common, so V by R1 plus V by R2 plus V by R3. So I'm cancelling V because V across each and every resistor is common. So what happen is 1 by R net is equal to 1 by R1 plus 1 by R2 plus 1 by R3. This is the thing which happens when three resistors are connected in series parallel connection. But for suppose if n resistors are connected in parallel connection, what happens is then 1 by R net is equal to 1 by R1 plus 1 by R2 plus and so on 1 by Rn. This was the thing happens when n resistors have been taken in parallel connection. So this is the very important formula you should remember. So if I am talking about what happens to current flowing in the circuit, what is the total current flowing in the circuit? If someone asks you, then what is the total current passing from the circuit is I is equal to V by R net, or as I said, V by R equivalent. Anything you can take into consideration. So this was the thing happens in parallel connection. Now always we can't do 1 by R net is equal to 1 by R1 plus 1 by R2 and so on 1 by Rn. For example, if two resistors are connected in parallel connection, then what happen is 1 by R net is equal to, I'm writing here for you, if two resistors are connected in parallel connection, are connected in parallel connection. So what happened in this condition? In this condition, 1 by R net is equal to 1 by R1 plus 1 by R2. So what happened is, if you simplify this one, 1 by R net is equal to, LCM is going to be R1 R2, and this is R2 plus R1. So this can be written as 1 by R net is equal to R1 R2 R1 plus R2 by R1 R2. So what is R net in this condition? R net is equal to R1 plus R1 R2 divided by R1 plus R2. This is a simple shortcut which you can use when two resistors are connected in parallel connection. So these are the things which we have discussed. So I have up to now what I have said is the formula according to series connection, formula according to parallel connection, and if two resistors are connected in parallel connection, what is the scenario which will happen is R net is equal to R1 R2 by R1 plus R2. These are the things which I have explained. So right now concentrate few sums so that which will feel us confident that yes, we can do this type of sums. So let's go with the problems on series and parallel connection. So the important thing which you should remember is across the resistors, voltage is common in parallel connection. Across, if I am talking about in series connection, 1 minute, just. So now we are going to discuss few problems on series and parallel connection. So let's start the problems on series and parallel connection. For example, if I'm taking this one, let's talk about simple circuits in the starting condition, and then we will discuss the difficult problems once we have done with the simple problems. So this is battery, this is resistance 1, this is resistance 2. Now, very simple question. This is a battery of 10 volt. Then this is a resistance R1. This is a resistance R2. And what is given is R1 is equal to 3 ohm and R2 is equal to 2 ohm. Then find R equivalent. Find R equivalent. Second question is find current in the circuit. I find current in the circuit. Then how you can find out is, first of all, you should find out R equivalent. So what is R equivalent? In this circuit, R1 and R2 are in series connection. So R equivalent is nothing but R1 plus R2. So it is going to be 3 plus 2. So it is going to be 5 ohm. So I is equal to, we know, V by R equivalent. So V is how much? V is nothing but 10 volt by 5 ohm. So it is 2 amperes of current. So I is equal to 2 amperes. I is equal to 2 amperes. So the total first question is R equivalent. R equivalent is going to be 5 ohm. And what is I? I is nothing but 2 amperes. So this is all about the question. So let's go with the next question. For example, if two resistors are connected in parallel connection. Let's talk about two resistors are connected in parallel connection. Let's talk about this thing, this condition. So now what happened is, let's talk about, this is a 10 volt battery. This is one resistor. This is one resistor. This is one more resistor. This is one resistor. And this is one resistor. So what I want to do is, this is of 10 volt battery. This is 2 ohm. This is 3 ohm resistor. This is 5 ohm resistor. This is 3 ohm resistor. This is 2 ohm resistor. So what is R? The question is find R equivalent. Find R equivalent. Second question is find I in the circuit. Find I in the circuit. So what is R equivalent? So if you see these two conditions, these 3 and 2 are in series connection. So this total R equivalent is going to be 5. So 5, again these two resistors are in series connection. So again this is going to be 5 ohm. So 5 ohm and 5 ohm are in parallel connection. So 1 by R equivalent is equal to 1 by 5 plus 1 by 5 plus 1 by 5. So this is going to be 3 by 5. So 1 by R equivalent is going to be 3 by 5. So R equivalent is going to be 5 by 3. So what is the current flowing in the circuit? Current is nothing but I is equal to V by R equivalent. So what is V? V is nothing but 10 volt divided by R equivalent. R equivalent is nothing but 5 by 3. So it is going to be 30 by 5. So it is going to be 6 amperes of current. 6 amperes of current is flowing in the circuit. So I think so you understand this question. Let's go on discussion with one more question. Let's make somewhat complex situations and let's solve those things. Let's call this is a circuit. Let's call this is a circuit. And let's call one more like this. So let's discuss the question. Let's solve the question. This is a battery. This is a resistor 1. This is a resistor 2. So this is one more resistor, here one resistor, here one resistor, here one resistor. So now solve the question. This is a 24-volt battery. If this is 24-volt battery, this is 12 ohm battery, this is a 12 ohm battery, this is a 6 ohm battery, this is a 6 ohm battery, this is a 12 ohm battery. So we want to find in this question we want to solve two things. One is find R equivalent. The first question is find R equivalent. The second question is find I, which is nothing but current in the circuit. So how to solve this question? This question can be solved very easily. R equivalent is going. These two are in series. Let's call this one as R equivalent 1 for these two circuits. And these two are in series. And let's call this one as parallel. So let's call this R equivalent as R equivalent 2. So what is R equivalent 1? R equivalent 1 is two circuits are connected in parallel. So the shortcut is R equivalent is equal to 12 R1 R2 divided by R1 plus R2. This is the shortcut when we have resistors in parallel connection. So this is going to be 12 into 12 divided by 12 plus 12. So which is going to be 6 ohm. So R equivalent 1 is going to be 6 ohm. So in the same way, these two resistors, 6 and 6 are in series connection, 12 and 12 and 12 again in parallel connection. So R equivalent 2 will be also going to be nothing but 6 ohm. So total again this 6 ohm, R equivalent 1 and R equivalent 2 are in series connection. So R net, the final R equivalent is going to be R equivalent 1 plus R equivalent 2. So this is 6 plus 6 ohm plus 6 ohm, which is nothing but 12 ohm. So what I want to find out current also. So current is nothing but V by R. So V is 24 volt. So 24 divided by 12. So which is nothing but 2 amperes. So I is going to be 2 amperes, which is showing in the circuit. And this is my second question. And what is my first question answer? R equivalent is going to be 12 ohm. This is all about series and parallel connection. There are many things to discuss in the series connection. So first today I am ending the meeting for you. Thank you, students.